Hello everyone, welcome back to the channel. Today we are going to understand linked list basic in C++. So what's linked list? Linked list is a linear data structure. So let's write it here. A linked list is a linear data structure. Linear data structure means that mean all the elements are arranged in one after another, like in array. Array is also example of linear data structure. So the question arises, what is the difference between array and the linked list? So we will note difference here. Differences between array and linked list. So as we know that in array, elements are stored in continuous memory allocation. In array, elements are stored in continuous yes, memory blocks. Memory blocks. But in linked list, each element is stored separate object like node, and each node points to the next node. Let's each element is separate object and we call it node, and each node points to the next node. One. So how a node looks like? Let's say here node contains, so nodes contain some data value, some data, you can say like integer, and second the node contains a pointer to the next node. So let's take a visual representation of nodes. Let's think this is the node, and this part contains data value, and this contains pointer, address of next node. So let's say example, let's make nodes like this. Let's any data value like 5, and this is pointing to this, and this let's say 2, and this is pointing to this contains 1, and at last it pointing to null pointer. Null pointer means no address. So let's say its address is 1008 and its address is 1012, 1016. Then this will store the address of this. Then second node will store the address of the third, and first node will store the address of second. So this will have 1012, and this will have this address 1016, and this will point null. If you want a real life example, then you can say like treasure hunt. You find a clue and that clue tells you where the next clue is. So you go there and find another clue and so on. This is also example of linked list, and another could be suppose a human chain. So like this is the man, and this is the next man holding the hand of Next, similarly, this human chain are connected with each other. Forward node. This is also example of linked list. So let's understand the types of linked list. Types of so first is single linked list. Single linked list. In this, each node points to the next node only. Let's write it here. Each node points to next node only. Node only. So if you want example, then let's suppose this is the node having value 1 and this is pointing to another node with value 2, and this is pointing to the next node with value 3, and this is last pointing to null pointer. And second type of is doubly linked list. In this, as name suggests, in this each node points both the next node and the back node and previous node. Let's suppose this is the node. This will have the value, let's say 1, and these are the two pointers for providing the previous node reference previous node, and this for the next node. Let the next node be having the value 2, then this pointer will point it here, and this will point its previous node, and let's suppose this is initial, then this will point null, means node. So, and again, let's it be next node having the value 3, and then second node will point to the third node, and third node previous will point this previous node, and at last, if it is last node, then this will point null since no next node is there. So this is the example of doubly linked list. Moving forward, and then circular linked list. As name suggests, the last node will point back to the first node. Back to the first node. By this way, they make a circle loop. Let's see example of it. So this is the node where we having value 1, and this will point to the next node having value 2, let's suppose, and this will point again to the next node having value 2, and this will again point the first node. So by this way, it makes a loop, and it is an example of circular linked list. Moving forward, now we are going to understand the node structure in C++. So let's understand the node structure in C++ language. So struct link node, it is a named variable name, let's integer value if we want to store integer in our linked list, and pointer. Next, and here we will create a function link node constructor. This will initialize our value x. This is x equals to x, and next will initialize with initial with null pointer. So this is the structure of our node. In this val, this stores the actual data set, and next in this next is the pointer to the next node, and this is the constructor which will initialize the value of next and val. First it sets the next equals to null pointer. So now let's look.
Let's create a linked list. Creating linked list. Suppose we want to create a linked list. Let's say this one pointing to the next node 2, and this pointing to the next node 3, and this will point null, means no. So how we will do in C++? Previously we have created the structure, so using this structure we will now create this linked list. So list node, let's make node 1. This is the name. You can do as you want. Using new keyword we will create list node and initialize the value with 1. Again list node 2, using new list node with value 2, list node 3, new list node with value 3. Now till this point we have created 3 node. This is our first node, this is our second node, this is our third node. Till now everyone is having null value in this, null value and null value. Now we will give the pointer address of next node. So in node 1 next equals to node 2. So by this we are storing address of this in here. So this will have the address of second node, and similarly node 2 next equals to node 3. Similarly this will have the address of third node. So by this way they are all associated with each other, and at last we have to mark any node as a head, means starting node. So we will mark node 1 as a starting node. List node, let's name it head, means start node. You can, so here we are making start node 1, means this is our head node, starting node. We, for traversing or printing, we need to know the starting node. So now question arises that why should we use linked list? Why should we use linked list? So let's differentiate this. Let's say array and linked list. In array we have fixed size, but in linked list are dynamic in nature, means you can add as much as nodes as you want and connect it. And in array, while inserting and deleting in the middle, we need to shift them. You need to shift, required shifting while inserting or deleting. or deletion of some elements, but in linked list no deletion are required, not such requirement. So these are the positive facts, but there are some limitations to linked list also. Limitation: you can't directly access, let's say, fifth node. So directly access not possible here. There are various common operations in linked list. We will see here operations in linked list. List. Let's see. First is traversal. We need to traverse and print the linked list. Second, reverse linked list. Third is finding middle node, middle node. Fourth is deleting a node, and fifth is deducting cycle. So we will see this in our next upcoming videos. So summarizing what we have done, that a linked list is made up of nodes. Summary: linked list is made up of nodes, and each node has data and pointer that points the next node. Dynamic in nature, dynamic. And next, it supports fast insertion and deletion. So thank you for watching. Please like, share and subscribe.